We had the privilege to see the worldwide launch of the new projectors for Epson in IFA, the R4000, the R2000. But what makes those work so well is the technology that's inside. And Carla, you're going to explain to us exactly what that means, the R for reflective.
Yes, of course. So this is really a revolutionary technology. The R stands for reflective. The projection technology we are using in the home cinema markets are fundamentally two. So the first one is transmissive, which is based on HTPS, so high temperature polysilicon LCD panel. This is known as 3 LCD systems. Then we have the reflective technologies, which are mainly DILA, which is by JVC, and SXRD, which is by Sony, and these are LCOS, liquid crystal on silicon technology. Then we have the DMD by Texas Instruments, which is used in the DLP, both mono-chip and 3-chip projectors. This new technology by Epson is actually a reflective technology, but is not an LCOS technology, because instead of being based on silicon, it's based on quartz. So it's using the core technology of Epson. So you know that the 3LCD projector are using 3 panels to form the 3 monochrome images which are then composed by the prism. We use the same, really the same system for the reflective technology. The difference is the construction, so where the single chips are located inside the optical engine, and the fact that these panels are reflective. So what we have done, we are using the same production process that we are using also for the transmissive panels. We are using now the D7 generation of processing production systems. These are very advanced panels, so we are using an inorganic material as base for the liquid crystal, and we are using vertical alignment, which is easier to control and to manage inside the projector. What we have done is that in the transmissive system we have a transparent electrode, which is the base on which the TFT, so the thin film transistor, are located. In the reflective system we substituted this electrode by an aluminum electrode, which is not transparent, and this is the key of the technology, because using this non-transparent element we could hide, let me say, all the sensitive technology, so the TFT and the Boson gate line behind this electrode. And this means that we could remove what is the black mask, so the element which is protecting from the lamp light the TFT, these are very sensitive components. They are getting inefficient, they get burned by the lamps, so you need to protect them with the black mask. With the reflective technology, the TFT are behind a non-transparent element, so we could remove the black mask. And this gave us an incredible advantage, because we could remove the black mask, so the aperture ratio was increased, and we could make the screen door effect no more noticeable by end user. So this is, you have now a system which is really a cinema experience system.
And for the viewers out there that haven't seen it, it's an enormous jump forward in terms of contrast ratio.
Yeah, of course. The other aspect, let me say, the 4 big advantages we have with these new technologies. The first is the incredible native contrast we can achieve. The R4000 has 40,000 to 1 native contrast, which is 8 times more than the standard contrast of the cinema transmissive panel. For the R2000 we have 25,000 to 1 contrast. These are really incredible. Then we have a panel which is by 70% quicker in response time than transmissive. This is really a huge revolution for high definition content, so the panning is smoother. And then we have the aperture ratio, which is very big, and the final is that the gamut has been increased. We can cover really a big color space. With this new system, we can match exactly the HD TV space color.
Okay. Well, thank you very much for this explanation, and I'm looking forward to seeing you again soon.
Thank you very much. Bye.